Good morning everyone. Today we're going to talk about bacterial culture and the different media we use to grow and also identify microbes. Before we start, Natasha, can you tell me what do you know about culture media?
Sure, the culture media are raw media used to grow, isolate, cultivate and identify microorganisms in the laboratory which can help in the diagnosis and treatment of infectious diseases. There are liquid and solid type of culture media such as alcohol and slime. The basic idea of culture media is that which is a combination of sustained and undesignated condition. It creates a suitable and natural environment for the microorganism to live.
Okay, good job. Now let's talk about selective and non-selective culture media. Carmen, can you briefly explain and bring some example of culture media?
Sure thing, Dr. Asmini. First of all, I think it's important for you to learn about the differences between selective and non-selective culture media. Selective culture media contains specific components that inhibit the growth of certain microorganisms while encouraging the growth of the others. These components can be added to the medium to create a selective environment. For example, we can add antibiotics, antiseptics, chemicals, dyes, antiseptics, sodium salts, whereas non-selective culture media support the growth of a wide variety of organisms without any inhibitory substances. So here are some examples of selective and non-selective culture media. This is nutrient agar. Nutrient agar is one of the most common non-selective medium that supports the growth of a wide variety of bacteria. We use these to isolate and identify bacteria from clinical specimens. It is also the earliest culture media used in clinical microbiology, and they are not specific to any particular microbe. This one is MICROBIOLOgy agar, which is a selective medium that inhibits the growth of gram-positive bacteria and allows only gram-negative bacteria to grow. For example, MICROBIOLOgy agar contains bile salts and also crystal violet, which inhibit the growth of gram-positive bacteria. It's commonly used to isolate enteric bacteria like E. coli and Salmonella.
Besides MICROBIOLOgy agar, CAD agar also is a selective medium that is used to isolate urinary tract pathogens.
I see. So what is the problem with non-selective media?
The problem with non-selective media is that it does not allow us to isolate specific microbe. Therefore, we need to use selective media for that purpose.
That's interesting. I had no idea there were so many different types of media.
Yes, there are many types of media that we use depending on the clinical situation. Like for example, we might use blood agar for bacteria growth that requires extra nutrient, and also sabar agar to grow fungi.
Okay, how did scientists develop all of these different types of media?
That's a great question, Natasha. The development of culture media has been ongoing process since the early days of microbe. Initially, the scientists used simple media such as nutrient broth and also agar to grow these bacteria, but they quickly realized that the different bacteria requires different nutrients to grow. Therefore, as a result, they begin to add different type of media to support the growth of the specific type of bacteria.
Yeah, that makes sense. But how do scientists know which ingredient to add?
Well, there are a few different ways. For example, sometimes the scientists will analyze the chemical composition of the bacteria to determine what nutrient they require. Or otherwise, they might just use the basic thing, which is trial and error. They add different type of ingredient to a basic medium and observe which bacteria grow. This added element is also called as enriched culture media. These are essential to grow bacteria. They might add some nutrients like water, carbon, and also other nitrogen sources, mineral salt, and some other energy sources to grow and enrich the growth of microorganisms.
Oh, that sounds like a lot of work.
Yeah, it is. It is also incredibly important. Culture media is one of the fundamental tools in clinical biochem. In clinical microbiology, it is essential for treating and also diagnosing infectious diseases. And besides adding the nutrients, sometimes it may also be necessary to add growth factors such as purine, amino acids, vitamins, remnant fluid, antioxidants, and even blood and also its derivatives to boost the multiplication of bacteria. And the development of culture media is an ongoing process. The scientists are always looking for new and better ways to identify and grow bacteria.
That's right. For example, the molecular method of identifying bacteria is now does not require culture. They use DNA instead. These methods are faster and more accurate than the normal culture method that we do. But still, it is expensive and not widely available.
It's amazing how much has changed since the early day of microbiology.
Yes, it is, and it's exciting to think about what new development might be on the horizon. So that's all for today. I hope you all learned something new about bacterial culture through selective and non-selective condition, and regarding the evolution of culture media through clinical microbiology.
Yes, I did. Thank you, Doctor.
Thank you, Dr. Asmini.
You're welcome. See you both tomorrow.